Hi all, welcome back. Wish you a very happy new year. So today we are going to solve questions from straight lines which came in different shifts of April 2025 attempt. In straight lines we have total 10 questions out of which 5 are easily doable and 5 are moderate which we are going to solve. This difficulty level is basis my perception which may be different for others. So let's move on to our first question. Before we start, here we have under analysis of questions, underlying topics, some main concepts in questions for each and every question with the difficulty level. Hope this will be helpful for you. Here is our first question. Our question says let A, B, and C be the vertices of a triangle ABC. Then the maximum area of parallelogram AFDE formed with vertices DEF on the sides BC, CA, and AB of the triangle ABC is. So, let's say here we have a triangle. Now, A, B, and C. Here is our triangle, and our point D is on BC. E is on CA. And F is on AB. And we need to find the maximum area of parallelogram AFDE. Area of parallelogram AFDE. Now, the area of parallelogram AFDE will be maximum if B, E, and F are midpoints of the respective sides. Then area of AFDE will be is maximum. Now our point A will be 4 comma minus 2. 4 comma minus 2. Point F will be is midpoint of A and B. 5 comma 2 minus 1 comma 2. D midpoint of B and C will be 5 comma minus 1. And E midpoint of A and C will be 13 upon 2 and minus 5 comma minus 5 upon 2. Now our required area is equal to 1 upon 2 mod of sorry 1 upon 2. This is a shortcut formula to find area of parallelogram. First let's write A. It's not even shortcut, it is on I think most of the books. So formula is write a point A, then the next point 5 comma 2 minus 1 comma 2, next point 5 comma minus 1. This is a shortcut to find area of any kinds of shapes. With 3 sides, 4 sides, till so on. We have point D will be 13 upon 2 minus 5 upon 2. And now we have to again repeat the point A, 4 and minus 2. Now this is equal to 1 upon 2 mod of this determinant. This will be, first let's take the right hand side part like this. Then we will get minus 2 minus 5 upon 2 minus 25 upon 2 minus 26 upon 2. Now with the minus we will add these multiplications or subtract. Now minus of all of these multiplications, this will be minus 5 minus 5 minus 5 by 2 minus 13 by 2 and minus 10. Now from here we will get this is equal to 1 upon 2 mod of this will be 15, or first let's cancel minus 5 by 2 and minus 5 by 2, because here we have minus, and from here we will get minus 15 minus minus plus 15 minus 2 will be 13, and 13 by 2 minus of 51 by 2 will be 38 by 2, which is 19. So minus of 19. 13 minus 19, and this is equal to 13 minus 19 minus 6 mod of 6. Mod of minus 6 will be 6. 1 upon 2 into 6 will be 3. So from here our answer is 3. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, let the area of the triangle formed by a straight line L with coordinate axis be 48 square units if the perpendicular drawn from the origin to the line N makes an angle of 45 degrees with the positive x-axis, then the value of b square plus c square is. So here in this question, let's write the steps. First step will be draw a graph. Second step is find B from the graph, makes an angle of 45 degrees. And the third step is find C from given area. And the last step, find B square plus C square. Now, the graph for this will be Now here we have our line, and if perpendicular drawn from the origin, this is y-axis, this is x-axis, perpendicular drawn from the origin, so makes an angle of 45 degree with positive x-axis. Now I have this angle is 45 degree, this angle is 90 degree, and sum of all the angles in triangle is 180 degree. From that, this remaining angle will be 45 degree. Now whole line is 180 degree. This is 45. This part will be 180 minus 45, 135 degree. Now from here we will get n is equal to tan of 135 degree, which is minus 1. Now slope for the line L will be minus 1 upon p, which is equal to slope, which is minus 1. From here b is equal to 1. If b is equal to 1, we will get b square is equal to 1. Now we know b is equal to 1, so the line will be x plus y plus c is equal to 0. So this point where y is 0 on the x-axis will be minus c comma 0. This point where x is 0 on the y-axis will be minus 0 comma minus c. From here our area is equal to 1 upon 2 c square, which is equal to 48 according to the question. C square is equal to 96. From here b square plus c square is equal to 97. From here we can say that our option C is correct. And here is our solution. We can see that our answer is correct. Here is our next question. This time our question says a line passes through the origin and makes equal angles with the positive coordinate axis. It intersects the line L1 and L2 where p is greater than 0 at the points A and B. Respectively, if AB is equal to this and foot of the perpendicular from the point A on the line L2 is M, then the value for this ratio is equal. So again, here in this question, first step will be draw graph. First step is draw graph. Second step will be first let me draw the graph, then we will look at the second step. Our graph will be our line L1 2x plus y plus 6 is equal to 0 will be like this, 1, and L2 will be like this, L2, because p is greater than 0. Now line passes through origin and makes equal angles with positive coordinate axis. It will be y is equal to x, because y is equal to x passes through the origin and also subtends equal angle from positive x-axis and positive y-axis. Now, according to the question, this is point A and this is point B. Now let's take this figure apart. We are left with, I have done this because of ease of representation. Now this line, let's say this line is y is equal to x. This is y is equal to x. And here we have L1, here we have L2. This is A, this is B. And the foot of perpendicular from point A is M. This is a graph. I made this graph only to represent the triangle ABN. Now, from here, second step will be find triangle ABM. Third step will be find AM upon BM using AM upon BM using tan theta, because let's say this angle will be theta and here we have 90 degrees, so AM upon BM will be tan theta. From here, AM upon BM is equal to tan theta. Theta is angle between y is equal to x and L2. Now the slope for y is equal to x, let's say is m1, which is equal to 1. Slope of L2 will be m2, which is equal to minus 2. From here we will get this is mod of m1 minus m2 upon 1 plus m1 m2. From here this is equal to 3. So our answer will be option D. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, let the equation, here we have this equation, have equal roots. Then the distance of this point from this line is. So, here in this question, let's write the equation as x square plus 2x, multiplying these two. Into 12 minus k is equal to 2. Now here, let our 12 minus k be equal to lambda. So from here we can say k should not be equal to 12. If k will be equal to 12, this will be 0, and 0 is equal to 2. It is not possible. Now, from here we will get lambda x square plus 2 lambda x minus 2 is equal to 0. Now, let me also write the processes to solve this question. First step is substitute 12 minus k is equal to lambda. Second step will be equate discriminant is equal to 0. From discriminant equal to 0, find lambda, then k, and the last step, find required distance. So now let's put discriminant is equal to 0 here. From here we will get 4 lambda square. 4 lambda square plus 8 lambda is equal to 0. From here we will get lambda is equal to 0 comma minus 2. Now lambda is equal to 0 is not possible, because when lambda is equal to 0, we will get 0 is equal to 2, which is not possible. And lambda is equal to minus 2, this is possible. Let's take lambda is equal to minus 2. From here we will get k is equal to 14. And our point, let's say this point is P, our point P will be is equal to 14 comma 7. 14 comma 7 from now, yes, so now let's find the required distance. Our distance from point P to the line will be mod of 14 into 3, we can write it as 7 into 6 plus 7 into 4 plus 5 upon under root of 16 plus 9. This is equal to 7 times 10 plus, which is 70, and plus 5 75 upon 5. From here we will get b is equal to 75 upon 5. b is equal to 1 5. From here we will get our answer is option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, consider the lines this lambda being a parameter all passing through a point P. One of these lines is L, is farthest from the origin. If the distance of L from this point is D, then the value of D square. Now first let's write this line neatly. We will get x plus 2y minus 5 x plus 2y minus 5 plus, let's take lambda common, then we will get 3x plus 7y minus 17 is equal to 0. Now let me check once more. Yes. Now this line will pass through the intersection of these two lines. X plus 2y minus 5 is equal to 0. We can write this as x is equal to minus 2y plus 5, and this is equal to 0, which is 3x plus 7y minus 17 is equal to 0. Now let's substitute x is equal to minus 2y plus 5 in this line. Then we will get minus 6y plus 7y, which is y plus 15 minus 17 is equal to 0, so y is equal to 2. Y is equal to 2, then from here x is equal to 1. So here in this question we have passes to point B. Let's say B will be 1 comma 2. Now let's start writing the steps for this question. First step is, which we have done already, find P. Second step will be find L, and third step will be find D square. Now we need to find L from graph. We'll see more when finding the line L using graph. From graph. Now let's make a graph. First, let's take this. Now let's draw a graph, and let's say here we have origin and here we have P, which is 1, 2. Now the line which is farthest from the origin will be perpendicular to origin and the point P. This is perpendicular. So from here, slope of O and P, origin is again 0, 0, will be m is equal to 2 minus 0 upon 1 minus 0, which is 2. If this is 2, then slope of line will be minus 1 by 2. So from here we will get y minus 2 is equal to minus 1 upon 2x minus 1. From here we will get 2y plus x, 2y plus x, and minus 5 is equal to 0. 2y plus x minus 5 is equal to 0. And please wait a minute. Yes. Now we need to find distance from the point 3, 6. So our d square, let's directly write d square. Our d square will be square of mod of 12 plus 3 minus 5 divided by root of 4 plus 1 whole square. Now this will be 100 upon 5, which from here our d square is equal to 20. From here we can say that our answer is option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says let the three sides of a triangle are on the lines this, this, and this. Then the distance of its orthocenter from the orthocenter of the triangle formed by the line this, and this. Now, on observing the question closely, when we will see the first three lines, these two lines are perpendicular. When we will see the next three lines, these two lines are perpendicular. So in this question, first step will be make right angle. Sorry, first step will be find orthocenter from right angle triangle. Both are because right angle triangles. Second step will be find the required distance Now let's plot the first triangles. Now this hypotenuse will be x plus y is equal to 5. Let's say this is 7x plus 4y is equal to 15. And this is 4x minus 7y plus 10 is equal to 0. Here we have A, B and C. Now I said these are right angle triangles because the slope of this line will be 10 is equal to minus 7 upon 4 and slope of this line is 4 upon 7. Now we can see when we will multiply these two, we will get minus 1. This means these two lines are perpendicular. Now these two lines are perpendicular, so from here our orthocenter for this triangle will be point B. To find point B, we need to find intersection of 7x plus 4y is equal to 15 and 4x minus 7y is equal to 10. We can write this as x is equal to 7y plus 10 minus 10 is equal to 0. So plus 10, not minus 10. We will get 7y minus 10 upon 4. Let's put this in the first equation. Now we will get 49y minus 70 upon 4 plus 4y minus 15 is equal to 0. From here we will get 49 plus 16 49 plus 16 we will get 65y 65y and 4 times 15 will be 60 plus minus 60 minus 70 will be minus 130 is equal to 170. Our y is equal to 2. Y is equal to 2. If y is equal to 2, then x will be equal to 14 minus 10, 4 upon 4, 1. From here, we will get B is 1, 2. 1, 2 and B is the orthocenter. And same for the next triangle. Next triangle is also right angle triangle because this is y is equal to 0 or x-axis. Here we have x is equal to 0 or y-axis, and here we have x plus y is equal to 1. Let's say this is PQR. Again, Q is orthocenter. Q is orthocenter, and coordinates of Q is simple intersection of x-axis and y-axis is at x-axis and y-axis is at origin. So from here, distance between B and Q will be under root of 4 plus 1, 5. From here, our answer is option B. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says let ABC with a triangle such that equations of line AB and AC be this and this, respectively, and the points B and C lie on x-axis. If P is the orthocenter of the triangle ABC, then the area of the triangle PBC is equal to. So here first, let's plot the graph. Now here we have x plus y is equal to 2. X plus y is equal to 2, and the other line, let's not write x plus y is equal to 2. Other line is 3y minus x is equal to 2. This will be like this. Now this point is our A. This point, let's say, is B. This is C. Our point B will be minus 2 comma 0. Point C will be 2 comma 0. Now P is the orthocenter of this triangle. So here, let's say we have orthocenter. Sorry, here we have made perpendicular from A to the side BC, and this is an obtuse angle triangle. So let's extend it, because in obtuse angle triangles, our orthocenter comes outside the triangle. Now we need to make a point of perpendicular from side A on side AC from the point B. So this will be like this. This is perpendicular, and here we have our point P. Now I am not taking the other C because we need to find P, then the area of PBC. So our triangle is PBC. Now here we have P, B, and C. Now we need to find the point B. To find point we need to find the point P. To find point P first, or before writing this, this is our line x is equal to 1, because our point A is 1 comma 1. On intersection, when we will see, this line is 3y minus x is equal to 2. This line is x plus y is equal to 2. From here, x is equal to minus y plus 2. Substituted in this line, we will get y minus 2, 4y is equal to 4, y is equal to 1. If y is equal to 1, our x is also equal to 1. So A is 1 comma 1, and it's a perpendicular straight line, so we can say this line is x is equal to 1. Now let's find equation of BP. Equation of line BP will be, now the slope of this line AC line, which is x plus y is equal to 2, slope of this line will be minus 1. So slope of BP will be plus 1. From here we will get y minus 0 is equal to 1x plus 2. So from here we will get x minus y plus 2 is equal to 0. X minus y plus 2 is equal to 0. When our x is equal to 1, our y will be equal to 3. From here, point B is 1. Now let's plot the triangle. We have point P, B, and C. So the area of this triangle PB and C will be area of triangle PBC will be equal to 1 upon 2 into base distance between B and C is 4 into height distance between point P and the x-axis will be 3. So this will be cancelled to this is equal to 6. From here our answer is option D. And here is our solution. We can see that our answer is correct. Here is our next question. This time our question is if the orthocenter of the triangle formed by lines this, this and this is at point this, then M minus C is. So here in this question, before writing steps, first let's draw the diagram. A, B, A, B, and C. Let's say this is y is equal to x plus 1, this is y is equal to mx plus c, and here we have y is equal to 4x plus 8. Now let's make a orthocenter here. Here we have our orthocenter, let's say h at 3, minus 1. Now let's find the coordinates of the point A. Now our y is equal to x plus 1 and y is equal to 4x minus 8. We will put y is equal to x plus 1 and y is equal to 4x minus 8. We will get 3x is equal to 9, x is equal to 3 and y is equal to 4. So from here our a will be 3, 4, or let's keep it as it is. Our a will be 3, 4. Now let's find point B, which we will find from intersection of these two lines. Y is equal to x plus 1 and y is equal to mx plus c. Putting y is equal to x plus 1 and y is equal to mx plus c, we will get x is equal to c minus 1 upon 1 minus m, and y is equal to c minus 1 upon 1 minus m plus 1. So our point B will be c minus 1 upon 1 minus m, c minus 1 upon 1 minus m plus 1. Now first our slope of AH will be 5 upon 0 infinity. If slope of AH is infinity, then from here we can say that slope of BC is equal to 0. If slope of BC is equal to 0, from here we can see slope of BC is m and n is equal to 0. Now we have m is equal to 0. We can rewrite this point as 1 c minus 1 c minus 1 comma c c minus 1 comma c. Now slope of BH is equal to slope of BH is perpendicular for this line and slope of AC is 4, so slope of BH will be minus 1 upon 4. From here we will get slope of BH is C plus 1 upon C minus 1 minus 3, which is C minus 4, is equal to minus 1 upon 4. From here C is equal to 0. So from here we will get m minus c is equal to 0. From here we can say that our option A is correct. And here is our solution and we can see that our answer is correct. Hi all, welcome back. Now we need to solve the next question. Sorry for the mistake, for welcome back. Here is our next question. This time our question says, a line passing through the point P makes an acute angle alpha. With the positive x-axis, let the line be rotated around point P through an angle alpha upon 2 in the clockwise direction. If in the new position the slope of the line is 2 minus root 3 and its distance from origin is 1 upon root 2, then the value of this expression is. So here in this question, we need to find the value of this expression is equal to. So first, let's draw a graph. Let's say this is point P and this will be at point Q. Now this makes an angle alpha. Now this line is rotated clockwise with an angle of alpha upon 2. This is R, alpha upon 2, alpha upon 2. Now the slope of the new position is 2 minus root 3. So our tan alpha by 2 is equal to 2 minus root 3. From here, alpha by 2 is equal to 15 degrees. Our alpha is equal to 30 degrees. And our point P will be, in the question is given a comma 0. This is not theta. This is not theta. This is 0. Now our equation of PR will be, equation of line PR will be y minus 0. Y is equal to 2 minus root 3 x minus a. Now distance from origin, let's say this is O. Origin is equal to 1 upon root 2 as given in the question. From here we will get distance from origin. This will be mod of root 3 minus 2a plus root 3a minus 2a minus 2a plus root 3a upon under root of 4 plus 3 minus 4 root 3 plus 1 plus 1 is equal to 1 upon root 2 according to the question. Now let's take 2 common. We are taking a common, not 2, a common. We will get minus 2 plus root 3. We will take it outside the mod. This will be a 2 minus root 3 upon. Let's take 4 common from here. We will get the root of 2 minus root 3. The 2 outside is equal to 1 upon root 2. From here we will get a is equal to 2 upon root 2 will be root 2. And from here we will get under root of 2 minus root 3. And 1 upon under root of 2 minus root 3. Rationalize it into 2 plus root 3 upon 2 plus root 3. In numerator we will get 1 upon 2 plus root 3, taking it to numerator. We will get root of 2 plus root 3. So from here we will get, here we have our value for a, yes, or we can write it as root of 4 plus 2 root 3. Now let's say this required expression is s. Our s is equal to 3 times a square, which is 4 plus 2 3 into tan square alpha. Tan of alpha is 30. 1 upon root 3 whole square, 1 upon 3. 3 and 3 will get cancelled out, minus 2, 3. From here our s is equal to 4 and a is equal to this. So from here we can say that our answer is option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This is our last question. This time our question says let A be the length of a side of a square OABC, O being the origin, its side OA makes an acute angle alpha with the positive x-axis, and the equation of its diagonals are this and this. Then alpha square is equal to. So first let's plot this square. Here let's say we have O, A, B, C. Let's rotate this. O, A, B, C. Now this is a square, and let's say this length is A as given in the question, and this OA side OA makes alpha angle, and let's let's say this is a diagonal OB and this is our diagonal CA. Now the diagonal OB is this one because this passes through origin, and OB also passes through point O, which is origin. Now because it's square, so this angle will be 45 degrees. Now first let's try to find the slope of OB. The slope of OB is equal to minus of, or let's write root 3 plus 1 upon 1 minus root 3. Root 3 plus 1 upon 1 minus root 3. So from which is equal to tan of 105 degrees. From here we can say clearly alpha is 60 degrees. Our alpha is 60 degrees, then now we need to find, if our alpha is 60 degree, we can say point A will be, now OA passes through origin O, we can say point A will be A cos 60 degree plus A comma A sin 60 degrees. From here we will get A, point A is A comma 2, A upon 2 comma root 3 by 2 into A. Now our point A lies on the diagonal AC, so our point A also lies on this diagonal. So from here, now let's take A upon 2 first common from these two terms. When we will take A upon 2 common from these two terms at the starting, we are going to left with root 3 minus 1 and minus 3 minus root 3 is equal to minus 8 root 3. Now root 3 will get cancelled. From here we will get minus 4 upon 2, minus 2, take it to the right hand side. A is equal to 4 root 3. From here we can say our A square is equal to 16 into 3, 48. So our answer is option A. And here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.